Hey, algebra students, today we are building on what we learned with parent functions, and we're going to be graphing considerably more complex functions, but using some tricks, I guess. And so we're going to be graphing functions by stretching, shifting, and also reflecting. And we'll see that a lot of the relationships that apply to one function family apply to all the others. Well, let's just quickly kind of recap what we've had so far. Maybe not all of them. In the previous lesson, we talked about like 6 different ones, maybe even more, but today let's focus in on some just the basics. So the parent function y equals the absolute value of x. So this is from the absolute value family. The parent function, the simplest version, is this, and we saw that when we graphed that, we wound up with a v just like this. Okay, well, the standard form for this is going to be y equals a times the absolute value of x minus h plus k. Okay, and so we saw on Desmos earlier in the lesson, if you were there in class, that each of these 3 things, the a, the h, and the k, have different responsibilities. They change the parent function in slightly different ways. The h value moves the function left and right, left or right. And this one's going to be the opposite of the sign, like we saw with circles. So if the h value is positive, we're going to go to the left. And if the h value is negative, we're going to move to the right. The k value shifted it up and down, up or down. But this was the same as the sign. If it's positive, it was going to shift up. If it was negative, it was going to shift this whole thing down. The a value was the stretch value. If a was greater than 1, it got more narrow. So if I had an a value of 2, you would get something that looked more like this. Okay, but if a was between 0 and 1, okay, that made it wider. Right? And so if I had something like 1/2, that would make it look something like that. All right, and then the other thing that we noticed was that when the a value was negative, when I had a negative a value, that reflected over the x-axis. Okay, and so if I were to take a look at each one of these, okay, if I were to take a look at the parent function of y equals the absolute value of x, if I were to have something like y equals negative 2 times the absolute value of x plus 3 minus 7, okay, well, it would be that parent function. I would start with that, and then I would know that I would shift it, and I'd probably just focus in on the vertex. I would shift that 3 to the left, and then 7 down. So 3 to the left, 7 down. And then because it was negative, I would know that it'd be flipped upside down. So instead of going up, it'd be going down. And the 2 would make it more narrow. And I'd have something like that. Okay? And so without having to use a graphing calculator, without having to do any real mathematical craziness, I can just simply graph that function. Now, what I want you to recognize is that when I have these forms right here, it's generally the same for everything. If I had y equals, say, the absolute value of x as my parent function, okay, we remember that that one starts at the origin and kind of looks like this. Okay, while in standard form, I'd have y equals a times the square root of x minus h plus k, and all of these things still apply. Okay, these 4 things, it still holds true. Okay, so again, if I had something like y equals negative 2 times the square root of x minus, I guess we'll say x plus 3 minus 7, Okay, what I would do is I would take that key point, like the vertex with absolute value, be the starting point with my radical function. I would move that 3 to the left. I'd move it 7 down. Okay, I would know because it was negative, it was going to go reflected. It was, if it goes like that, I'm going to go like that. And then the 2 makes it more narrow. It gives it a stretch. Okay, and so it look something like that. Okay, one other thing that you can do that would help you, especially if you have a shift, or not a shift, but a stretch. The shift is no problem. I can do that manually and get a very precise spot. But sometimes with the shift, it's a little hard to tell exactly what some of those points would be. So my advice to you is to just go ahead and graph the parent function with that stretch, pretending like that is the origin. So if I had, and maybe just do a quick little table here. So when x equals 0, square root of 0 is 0. 0 times negative 2 is 0. So, all right, that kind of puts me right there. But how about 1? Well, the square root of 1 is 1. 1 times negative 2 is negative 2. So if this were the origin, it's not, but I'm pretending like it is. If I went over 1, I would go down 2. And if I picked 4, I'd have the square root of 4 is 2. 2 times negative 2 is negative 4. So I went over 4, then I would go down 4. And so this is how I would kind of get an accurate picture of what it looked like with a stretch value. So we've done absolute value, we've done the square root. Maybe I'll just do one more. This pattern applies to pretty much all of them. And so we can just kind of continue with that. Maybe the square function or the quadratic function, y equals x squared. Okay, we know that the parabola looks like this is the graph of my parent function. Okay, but the standard form, which we've been looking at for each of the others, okay, would be kind of in the same form. Y equals a times x minus h squared plus k. Okay, and again, all of these 4 things apply to it. So if I had y equals negative 2 times x plus 3 squared minus 7, well, all I would have to do is, again, I take my key point, that in this case the vertex, I'm going to shift it 3 to the left, 7 down, 3 left, 7 down. And then, again, I know it's going to be concave down because it's negative, but exactly how am I going to do it with the stretch? I know the 2 makes it more narrow, but how much more narrow? Well, we could go ahead and just graph y equals negative 2x squared, pretending like this is the origin. So if I pick like 1, 1 squared is 1, 1 times negative 2 is negative 2, so over 1, down 2. And of course, because I know these are symmetric, I know I'd have kind of a place over there, and that's basically how it would look. Okay, so in a nutshell, that's what we've got. Let's take a look at some example problems. Just walk our way through it. If I have y equals 2/5 times the absolute value of x, well, all I have here is an a value. This one I can treat kind of like slope, like up 2 to the right 5 with the absolute value. Up, I know there's no shift, so I'm going to stay here. Up 2 to the right 5. Okay, but obviously I know what it should look like because I know what the parent function is for absolute value. So it's not going to go down here, it's going to go up on the other side, and so I wind up with something that looks like that. Okay, now here I've just added one more piece of complexity. I have 2/5 times the absolute value of x, so it's going to look like this. However, now I'm going to shift up 3. So my vertex goes up 3, but now I'm going to pretend like this is the origin and just do 2/5 times absolute value of x from here. So up 2 to the right 5, 2 to the left 5, and there is the absolute value of, or 2/5 times the absolute value of x plus 3. All right. How about this one? Again, just one added piece of complexity. This time I've got an x minus 4. Well, remember, this is going to be the opposite of the sign. So not only I'm going to stretch it, make it 2/5, not only am I going to go up 3, this time I'm also going to go to the right 4. And again, pretending like this is the origin, I will graph this guy, the 2/5 times absolute value of x. Up 2 over 5 would put me about there. Up 2 over 5 puts me about there. All right, now again, everything is the same except for this time I've got an a value, or I guess a negative a value, which means I would have exactly the same thing that I had earlier, except now I'm going to reflect it. I'm going to flip it upside down. So instead of going up 2 to the right 5, I'm going to go down 2 to the right 5, down 2 to the left 5, and, well, there it is. Okay, so that's kind of piece by piece how we would take care of that. We could go ahead and do that with quadratic functions as well. It's a very similar idea. We've got y equals 3 times x squared. Well, I know what 3 times x squared is, but or I guess x squared. But if I multiply it by 3, how does that change it? Well, I just plug in a couple of values. 1 squared is 1. 1 times 3 is 3. So I'd have over 1 up 3. And because I know it's symmetric, I've got a spot over there. If I needed to, I could do maybe one more, but I think that would be pretty well off the graph. So I'm going to call this good for now. Not pretty. Okay, now the rest of them, again, I'm just applying what I know. I've got plus 3, and so that's going to shift everything up 3. Again, I could pretend like this is the origin, and then just do the 3 from there. So like 1 squared is 1, 1 times 3 is 3, so I go over 1, up 3. And there's the graph of 3x squared plus 3. Now if I have minus 4, again, that shifts it 4 to the right. Still have up 3, and I'm still applying that a value to give me my stretch. Oops. All right, and then the last one here, just like the other one, well, if I've got an a value, okay, that's going to shift everything down. So instead of over 1, up 3, I'm going to go over 1, down 3, and there we go. I'm done. So this is what today is all about: shifting, stretching, and reflecting. All right. I can do just maybe want to show you one quick one here with the radicals. Well, we kind of already did that, so we'll just do this quickly. Again, how does that 2 affect it? Well, I know I'm still starting here at the origin, but if I pick like x equals 1, 1 square root of 1 is 1. 1 times 2 is 2, and so I got a value there. If I pick 4, 4 square root of 4 is 2. 2 times 2 is 4, so we go over 2. I'm going up 4, so over 4, up 4. And now I've got a pretty good idea of what it should look like. All right, but all the rest of them are simply just a shift. Okay, so this minus 3 means I go down 3. And I would do the same function here. So over 1, up 2, over 4, up 4. And you can see it's the same function, just shifted down 3. The rest, same as before. I'm going to move it 4 to the left. I'd reflect it, flip it up